Right now, as you're watching this, something invisible is carrying you forward. You can't stop it. You can't slow it down. You definitely can't reverse it. Here's what's going to mess with your head. The fundamental laws of physics work perfectly well in reverse. A ball bouncing, a planet orbiting, an electron spinning. The math doesn't care whether you play the tape forward or rewind it. And yet, you have never, not once, seen a shattered coffee mug leap off the floor and reassemble itself. You've never watched smoke funnel back into a candle. You've never gotten younger. So where did time come from? And why does it only go one way? About 13.8 billion years ago, the universe began. Not an explosion flying outward into pre-existing space. Space itself began to expand. And time started with it. Before the Big Bang, there was no before. As Stephen Hawking put it, asking what came before the Big Bang is like asking what's north of the North Pole. The question sounds reasonable, but it doesn't point to anything real. In the first 10 to the negative 43 seconds, a span called the Planck epoch, our understanding of physics completely breaks down. General relativity crashes into quantum mechanics, and neither theory can describe what's happening alone. During this moment, all four fundamental forces of nature are thought to have been unified. The entire observable universe was compressed into a space smaller than a proton. The temperature was around 100 million trillion degrees. Then something shifted. In a period called cosmic inflation, space expanded by a factor of at least 10 to the 26th power. Imagine a single bacterium inflating to the size of the Milky Way. In less than a trillionth of a trillionth of a trillionth of a second. When inflation ended, its energy was dumped into matter and radiation. Within 3 minutes, protons and neutrons began fusing into the nuclei of hydrogen and helium, and all the while, time was ticking forward. Relentlessly, irreversibly. But why only forward? For most of history, people assumed time was absolute, ticking at the same rate everywhere, for everyone. Then Albert Einstein dismantled that idea. His 1905 theory of special relativity showed that the faster you move, the slower time passes for you. In 1971, physicists Haefel and Keating proved this by strapping atomic clocks to seats on commercial airliners. They bought tickets for Mr. Clock and flying them around the world. When compared to reference clocks at the U.S. Naval Observatory, the traveling clocks had drifted by exactly the amounts Einstein predicted. His 1915 general theory of relativity went further. Gravity also warps time. The closer you are to a massive object, the slower time flows. This isn't abstract theory. It's something your phone deals with daily. GPS satellite clocks gain about 38 microseconds per day compared to ground clocks because of the combined relativistic effects. Without corrections, GPS positions would drift roughly 10 kilometers every day. Your navigation app would send you into a lake. But here's the unsettling part. Nothing in Einstein's equations says time has to flow in one direction. Relativity describes how time behaves, not why it only moves forward. For that answer, we need disorder. In 1928, astrophysicist Arthur Eddington coined the phrase, the arrow of time. He put it simply, follow the arrow and find more randomness, and you're heading toward the future. Less randomness, that's the past. The key is entropy, a measure of disorder. You can scramble an egg but never unscramble it. You can mix cream into coffee, but never unmix it. The reason is pure statistics. There are overwhelmingly more disordered arrangements of particles than ordered ones. When you smash a glass, the shards can land in billions of configurations, but there's only one where the glass is whole. This is the second law of thermodynamics. Entropy in an isolated system always increases or stays the same. Eddington himself said that if your theory disagrees with the second law, there is nothing for it but to collapse in deep humiliation. And here's where it gets profound. The reason entropy keeps increasing, the reason there's an arrow of time at all, traces back to one extraordinary fact. The universe started in an astonishingly low entropy state. The cosmic microwave background, the afterglow of the Big Bang mapped by NASA's probes, shows the early universe was nearly perfectly uniform. Temperature variations of only 1 part in 100,000. Roger Penrose calculated that the odds of such an ordered beginning are roughly 1 in 10 to the power of 10 to the 123rd. A number so large that writing it out would require more digits than there are particles in the observable universe. Because the universe started so ordered, entropy could only go up. That rising entropy is what gives time its direction. It's why stars burn out but don't spontaneously reignite. Why do you remember yesterday but not tomorrow? Hawking identified 3 arrows of time that all align. The thermodynamic arrow, entropy increases. The psychological arrow, we remember the past, not the future. And the cosmological arrow, the universe expands. He argued they're all connected, rooted in that improbable, low-entropy beginning. Why did the universe begin so ordered? The laws of physics don't require it. Some physicists suggest we should simply accept it as a fundamental fact of nature. Others propose that the Big Bang wasn't the true beginning, just a local minimum in a much larger, possibly eternal cosmos. We don't have the answer yet, and that honesty matters. What we do know is that time bends near massive objects, slows at high speeds, and its forward direction appears to be a consequence of statistics, of the simple fact that there are vastly more ways for things to be messy than neat. Trillions of years from now, the universe may reach maximum entropy, no stars, no planets, no distinction between past and future. Physicists call this the heat death of the universe. But right now, we're in the golden age. The universe is complex enough and energetic enough to support galaxies, sunflowers, and your consciousness watching this video. Every second that passes is entropy doing its thing, and the fact that you exist at all, in a universe that began in such an improbably ordered state, that's worth sitting with for a moment. If this video rewired something in your brain about time, hit subscribe so you don't miss what we explore next. Drop a comment. What question about the universe keeps you up at night? Your curiosity might spark the next video.